Hello students, welcome back to my class. Today we are going to talk about structure of atom, and here we'll discuss about Bohr's model. Okay, so how he modified whatever we have already, or our scientists have already given to us about atoms, how he changed a few things or modified few things to give us or to let us know more about atoms. Okay, so he discovered he did his, experiments around 1913. Okay. And he built it up on whatever already Rutherford has suggested us. Okay. So, and he also brought, you can say, a revolution in the field of quantum, you can say, theory. Okay. Or quantum electron or quantization of electrons. Basically, he talked about that. Okay. So, what exactly his vision was, let's discuss that. 1 second. Sorry. Yeah. Let me just pick up my pen. Yeah. Okay. So now he talked about actually the shells around the or in an atom, not around. Okay. So if this is an atom we are talking about, there are different energy levels, or you can say shells. Okay. And here in the center would be proton and neutron. Okay. This will be dense. Now, these shells can be called as K, L, M, N, and so on. Okay. And these electron shells are actually, they contain electrons in it. Okay. So, here will be the electrons. Now, how much electron each shell can contain, that was told by Bohr. Okay. So, the formula is 2n square. Okay, so for example, n is nothing but the number of shell. Okay, so basically, if like you can take, pick this one. This is the first, right? First shell. Okay, so the first shell, if you will put the formula here. So 2 into the first shell square is equals to 2. So only 2 electrons can be there in the first shell. That is K shell. Now, if we talk about L, so this becomes the second shell, right? So let's do a calculation. I'll do it here. So 2n square is equals to 2 into 2 square. And if you'll solve it, you'll get 8. Right? So in the second shell, you can only have 8 electrons to stabilize it and not more than that. Okay. So this was the idea of Bohr. Now, Neil Bohr, and also he talked about the energy relationship. So basically he said the electrons or the shells which are closer to the nucleus, they have low energy level. And the more far the shell is from the nucleus, it has high energy level. And that's why electrons will excite also. That is the reason. So he was able to give the reason of, electron excitement or change in the energy level of any electron. So this idea came through the head of this, genius. Okay. And electrons cannot exist between the orbits. He meant to say that electrons cannot be here or here. It has to be in one energy level or one, shell or one orbit, we can say. Okay. And it will jump around these, but it will never, exist in between the shells, you can say. Okay. So this is what he meant by the quantization. Okay. Now let's move ahead. So what was the merit? What do we get to know? So there was atomic stability, which was explained by Bohr, which wasn't explained by other, scientists. He was successfully able to explain why atoms don't collapse. Okay, despite having negatively charged electrons orbiting a positively charged nucleus, a major triumph over whatever Rutherford or other scientists model were. So basically, he was able to explain that if there is proton and neutron here, and this is positively charged, right? Positively. So if electrons are revolving, negatively charged electrons around it, why is it not, spiraling and coming here after losing the energy? Because it has certain energy and it does not stay or, in between the orbits. Okay. And this have very low energy, and the more higher energy ones stay out in the outer shell, Okay, and they are helpful in making bonds. So that we'll see later again. And he was able to explain about the hydrogen spectrum. Basically, the model accurately predicted the wavelength of a spectral line in hydrogen's emission spectrum. Now, you don't have to go in the depths of that because that might be a little bit more tricky for you. So I'm not explaining that here. We'll deal with that later. Okay. Now, a quantum foundation, again, he quantization of energy and charges, basically, he talked about that and connected the classical physics to the quantum mechanics and also the chemistry as well. Okay, so this is it. You can ignore this, okay? This down, whatever is written. Sorry, let me go back. This, okay, just ignore this. Nothing of that relevance. Okay, let's move ahead. So now you have few questions which you would like to do. This was an easy topic, right? I hope it was easy. Okay, so let's try a few questions. So the first one is, who proposed the concept of fixed electron orbits? So orbits are fixed and it is going to stay like that. Rutherford, Bohr, Thomson, or James Chadwick? So you can answer this. And then second question is, what are electron shells represented by? Is it, numbers only? Is it by K, L, M, N, X, Y, Z? Or is it no representation at all? We do not represent them at all. And the third question would be, when does an atom emit energy? Electron stays in the same orbit, then electron jumps to a higher orbit, then, or electron jumps to a lower orbit, then. So basically, this I'll tell you a little bit. So when electron jumps from one place to another, okay, then they emit energy. Okay, now exactly how they do it, why they are doing it, how much energy is there, all these things we'll discuss again in a depth class, or class where regular classes. So with this we are done. Okay, and we have discussed all this which we already know, like for example how Bohr was able to talk about the shells and give us the idea that why the electrons are stable and moving, like they are not actually stationary, but they are moving around the proton and they are in stabilized form. Okay, just ignore this image. Okay, this is irrelevant. Okay, so thank you so much for the session, and I hope you enjoyed the session. Try answering those questions, and you can contact me through my Urban Pro profile for any kind of more questions which you have, or if you want to discuss this topic in depth.